All right, so I am here to help you guys. I do want to let you know, I just put out a quiz 2, try 2. And that's because like I said, I did not intend for quiz 2 to be so different. I think also for some people, they just didn't get the connection of why it was actually supposed to be easier than some of the problems in the homework. But so I kind of just decided, well, I'm going to give you an option. If you want to try it again, you can do quiz 2, try 2. But if you submit quiz 2, try 2, you get that grade regardless of if it's higher or lower than the first one. So you have to decide if you want to look at it and you want to submit it, you have until midnight on Friday. So it's after the exam. Okay, any questions on that? Okay.
Oh, actually,
Yes.
I do have a question.
Okay.
Do you know what the class average was for the quiz? If not, no worries.
I haven't graded it yet. So no.
Okay, no.
And we can, and yes, you can ask Matt Cintron, you can ask questions about the quiz 2, either version, A or B, if you'd like. So
Oh, so the grade that's in right now isn't our actual grade?
the grade, you don't have a grade for quiz 2.
I mean, mine says 1 out of 10, so I wasn't sure what happened.
Oh, is that Anthony talking?
Yes. Yeah.
Anthony, you have in the feedback, you guys should always be reading the feedback I put on Brightspace. It says this is because you got a bonus point for catching an error during my lecture.
Oh, sorry. Okay, so obviously I didn't get a 1 out of 10, right?
No, it's 1 plus whatever you make.
Oh, geez.
On either, if you decide to do try 2, it'll carry over to try 2.
So are we going to know what our grade was for try 1 before we do try 2?
Nope.
Oh,
that's the decision you have to make.
For
with a partner.
oh,
Somebody was asking something. Yes.
Yeah, I said, can you still work with a partner on try 2, or is this one?
You can still work with a partner on try 2.
All right, thank you.
Sure. Okay. So who has a question for the exam? Let's see.
I'm still confused on I was looking at the quiz 2 solutions from quiz 2B, and I was still confused.
Okay. So maybe what I could do is go over quiz 2 version B.
Okay.
Would that
Sounds
work? Okay.
good.
Okay. So let me open up that that setup. Sorry, I'm getting there. Okay, so I guess what I'll do is I'll share the solutions, and then if we want, we can switch back to the whiteboard if I need to kind of write something out. So let me share my screen. Okay, let me know when you can see my screen.
Yeah, we can see your screen.
Did I pick the right screen? Are you seeing the solutions to in version B?
Quiz 2 project 1 version B. Topic linear programming.
Okay, good. Okay, let me zoom in on this a little bit. Okay. All right, so For those of you who did version 1 or version A, sorry, let me just catch you up. Basically, this is that you're starting a crypto club and you get a bunch of people to join, 30 people, and everybody's got to throw in $50, and then you got to figure out where you're going to invest it between Bitcoin and Ethereum. And you do a little research and you figure out the average rate of return for the Bitcoin is 18%, and the remainder and you're going to put the rest in Ethereum that has an average rate of return of 22.5%. So you explain that diversification is important, and so you have some constraints you impose on yourself. So you have at least 50% of the 1,500 will go to Bitcoin, and no more than 20% will go into Ethereum. So you have to write the linear program for that and solve it. And so the first thing is, because you're trying to figure out the amount that's going to go into each one, what you're going to want to be able, what you're going to want to do is, I'm going to attempt to highlight stuff here. I don't know. Oh wait, that's not going to work. Sorry, I'm going to figure out how to do a highlighter, but okay, I think this is it. Right, so you really want the amount that you invest in Bitcoin and the amount you invest in Ethereum to be amounts. So the unknowns are the amount of each into the amount of money that you're going to invest in each one. Okay, so let me just stop right there. Was there any questions on that part of it?
No, I'm just confused where you got the 1 and 1, like the ones
Oh.
and zeros.
Oh, okay, I got you. So, this is not totally necessary, but it's a way of setting up that table of information if you wanted to use a table information. So let me just stop sharing for a second and kind of talk about this on the whiteboard. So basically, you're going to have this condition that the amount that goes into the Bitcoin plus the amount that goes into the Ethereum has to be the 1,500. Now, if you look at this and you want to think about it in terms of the structure of the table, this has kind of like an implied 1 multiplied in front. So that's why in the table we have 1 and 1 for the coefficients, because that table is going to capture just the coefficients. All right. So then the second point, or what ends up being a constraint, is that we want at least 50% of the 1,500 to be invested in Bitcoin. So let's just say that the X is the one that we called, I think it is, right? X is the one that was Bitcoin, and Y was the one that was Ethereum. All right, so we want X, the amount that's going to go into Bitcoin, we want it to be at least, that means greater than or equal to the 50% of the 1,500. So that's 50%, 0.15 times the 1,500. So another way to write this, right? So I'm just going to rewrite this is 1 times X plus 0 times Y is greater than or equal to 750. And it's the 1 and the 0 that I just put into that table. Okay, and so then for Ethereum, we have that Y, the amount in Ethereum has to be no more than. So Y has to be no more than, that means it has to be less than or equal to 20% of the 1,500. So another way to write that is that it's 0 times X plus 1 times Y is less than or equal to 300. Okay, and again, so in the table, I put a 0, a 1, and 3, and less than or equal to 300. Okay, and then we have that
When
the
you
average. Yes, go ahead.
When you put the 750 and 300 in, when you put that under in Excel, do you have to do like what you did with the Y is less than or equal to 0.2 times 1,500, or could you just put the, like if you calculated the value on paper, could you just put 750 and 300 in those cells?
Yeah, you could, actually, the answer is you could do either. The solver will handle it if you calculate it in the cell in Excel, but if you did it on paper and then put it in Excel, that's totally fine. So
Oh,
then we
thank
had,
you.
okay. So so then we had the average rate of return, which we read about, which is what we want to maximize our return. So we're going to have an 18% of however much we put into Bitcoin plus a 22.5. So we got to convert those to decimals percent of what's going to go into Ethereum. And this is our, I'm going to call it R function, not for revenue, but for rate of return. And this is what we want to maximize. All right, so unless there's any more questions about this, I'm going to switch back over to the solution. Okay. So that's the table. So then when I put that into Excel, I went ahead and basically copied that over, and of course the cells were empty, the highlighted cells were empty until I ran the solver. Now I can show you an alternative way to do this. Let me get that open. Just so you get comfortable with, oops, sorry, I just want to make sure that I'm not revealing the answer to try 2 on the quiz inadvertently. Okay. All right, so here we go. All right, so here was what we did, right? What I just was showing you. I'm going to insert another worksheet right next to this one. And I'm going to copy this over, and I'm just going to show you a slightly different way that you could have done this and it would not have been wrong. So I'm going to copy this over and basically show you that. Now, if you got really, if you got good at doing, not that you're not already, but if you were doing these regularly, what I'm about to show you might be your preferred way. So I put this into the solutions in a sense. It was because I wanted it to match everything that we've been doing up till now. But another way we could have done it is to just ignore these 3 rows and put it directly in our constraints. Let me erase this. Okay, so we have just the average rate of return and then the amount of each that would be unknown. So what we could have done is just come right in here that the total amount to invest was equal to this amount plus this amount. And that had to equal 1,500. And then the amount that goes into Bitcoin could have just said, we just could have said that is going to equal this amount. And that has to be greater than or equal to 750. And that this cell was going to just equal this cell. So I'm just referring to the cells. Let me switch to formulas just so you can guys see that again real quick. And I just make sure I don't have any questions on kind of like why this was different, and if you can see that clearly. All right, you guys see that? Let me give you a second to look at that. Let me know if you understand what I did here. Everyone good? I don't know if silence means yes or silence means no.
Good.
Yeah, I'm
Good.
good.
Okay, you see how this isn't lining up exactly with the way we did the other problems, which is why the solution, I did it the other way. But you could just go in here and just set up constraints directly like that. So I'm going to go now into the objective function and I'm going to run over to the solver and I'm going to make sure I hit maximize and choose that. And then I'm going to add my constraints directly from here, drop down an equal to here. And then this one greater than or equal to 750. And then finally, the amount in Ethereum is less than or equal to 300. Okay. And we want non-negative, but we are okay with fractional for this problem. So hit solve. All right, well, that's fine. I'm gonna say answer, I'm gonna say okay. And so that we get 283.50. Before it was, whoops, wrong way, sorry. It was 283.50 the other way too, so. All right, so we get the same answer. The only difference is I didn't remove the non-fractional part. So we got this 0.0, this decimal way out here. I could run it without, with the keeping it integer level. I think that will be okay. Let me see what happens. Yeah, okay, it's the same thing really. Okay. So I just want to make sure you're clear on the logic of that, just because I think if you can follow both versions, I think you're really following the logic of what we're trying to do.
Could you go over again what you filled in for the X and Y? Because I'm kind of confused on how it's like still 1 and 0.
How I did it just now or the original solutions?
The original.
Sure. Okay. So, are you talking about these numbers right here? The ones and
Never
zeros
mind.
here?
I understand it now.
Oh,
Okay.
okay. You understand? Okay, no problem.
Makes sense. Thank you.
Sure. By the way, am I not at all visible? It's only the screen? Or am
I
I-
can see I can see your screen and you're in like a little box over to the right.
But I'm small, right? Because I'm sharing my screen so that mainly you can see my
Yeah.
monitor, right?
Correct.
Okay, good. Okay, good, good. Okay. All right. So I think that's it for the math behind quiz 2 version B. Then there was just writing up the memo. So hopefully everybody was clear on that. That was just sort of an expanded form of writing the answer as a sentence. So it's important that you do that.
When we write the memo, do we just explain like what investment would you'd see like a higher like rate of return or something?
Yeah, yes. You want to start out. So the memo template, I think, was trying to give you a little bit of guidance for that. Was you kind of, you don't want to waste anyone's time with a lot of backstory on what you did. You just kind of want to give them the answer, and then you give them a little background, a little background of where it came from to support it.
And
So it's not meant to be like an essay. It's just a memo. A memo is, like, think 3 sentences, 4 sentences.
yeah, and is it okay if we just refer to like our handwritten graph?
Um,
For like returns?
I think it's okay to refer to the Excel.
Okay.
You probably want to mention that you did this analysis in Excel and like in the solution memo. So actually, let's look at the solution memo. That might probably be the best thing to do. So I just pulled in a little logo for URI, and then I just said, based on the linear programming analysis conducted with Excel, the optimal allocation of the 1,500 would be to invest 1,200 in Bitcoin and 300 in Ethereum. Assuming an average rate of return on each of these cryptocurrencies of 18% for Bitcoin and 22.5% for Ethereum, the annual return on this investment allocation is expected to be $283.50. This allocation ensures, so then I just kind of go into a little bit of background, right? So the first part is giving the results of the linear programming and what we expect and what, kind of basically my recommendation to the club. And then it says, then I just give the background based on the constraints a little bit. So the allocation ensures at least 50% of the 1,500 is going to Bitcoin. It's actually 80%, and no more than 20% going to Ethereum. And I just kind of, made up this stuff about the stability. I don't really think Bitcoin is necessarily maybe stable, but okay. Then I just put, let us quickly vote on this recommendation and proceed to invest club dues. And then I have an attachment, quiz 2, project 1 LP. I put the name of the file. So that's basically all you need, something like that. Okay. All right. Again, silence, crickets. Okay, hopefully that's all right. Okay, so what else do you guys want to talk about? Do you want to do more linear programming? Do you want me to work through a linear depreciation problem? Do you want, what would you like to see?
When
If
is
you could,
the second version that we can do? Like our second try.
Sorry, what about the second try? I missed the
When is the
question.
due date?
The due date for that, it's on Brightspace, and it's going to be Friday at midnight. So it's down here, quiz 2, try 2. Okay,
Okay, thank you.
you're welcome.
do you think you could just run through a linear programming problem real quick?
Yeah, that's kind of, what's that word? Oxymoron. I don't know if I could go through really quick any
Yeah, no,
linear work, but
yeah.
I'll go through one. Okay, do you
Thank
have one in particular you'd like to see? Or do you want me to just,
No, not necessarily, just whatever, to be honest with you.
okay. All right, I got one. This book I was looking at. All right. So this is about a company called Ace Novelty, and they produce 2 types of souvenirs. Oh, and by the way, is my whiteboard now big again? Just want to make sure it's
Yeah.
not like a little tiny, teeny thing that people need a magnifying glass to see. You guys good? Can you see it?
Yeah.
Okay. All right. So they're going to produce 2 types of souvenirs. They call them very boring, no creativity here, type A and type B. And each type A souvenir will result in a profit. So type A has a profit of $1, and type B has a profit of $1.20. To manufacture a type A requires 2 minutes. I'm just going to say make. Type A takes 2 minutes. And on machine 1, and 1 minute on machine 2. And they're using Roman numerals, I guess, just to be fancy there. Okay. To make type B takes 1 minute on machine 1. And 3 minutes on machine 2. There are 3 hours available on machine 1. And 5 hours available on machine 2. How many souvenirs of each type would ACE make to maximize its profit? So here we go to the very end and we get the question. I don't know if for you guys or if it's just me, but all these problems start to seem the same to me. Maybe that's why I was drawn to the quiz the way I set it up. Okay. Okay. Silence my phone. Okay. How many of each type should ACE make to maximize profits? Alrighty. So step 1 is setting it all up, and then step 2 is solving it. So I'm going to go ahead and solve this one by hand. So let's go ahead and make sure we're all good on setting up the linear programming. So first of all, we definitely need to make sure we define, and I did see some people get this wrong already on the quiz. So you need to set these up as numbers, right? So always remember, it's got to be a number because we're doing math. So it's how many, right? And that's right there in that question. How many of each type? So X equals the number of type A souvenirs to make. Now, some people, if you don't know to go all the way down to the question, you may think that what you're trying to figure out is something about machine 1 and machine 2. And because there's 2 of those too, right? So that's where the question really keeps you clear on which of those, you know, what I'm going to call factors matter. So how many of each type should ACE make? So number of type A souvenirs, I can't spell it, souvenirs to make. And number of type B souvenirs to make. All right. So that much we got, right? So we got our unknowns. That's step 1, because we can't really go proceed much with besides unless we get those straight, everything else downwind from this will be wrong. And that's kind of why I'm really trying to make a big deal of you guys getting the variables straight right at the beginning. Always remember, you're trying to answer a question, right? If not, none of this, I mean, I wouldn't teach it in our class, maybe in some theoretical math class, but you know, we're trying to get to an answer to a business question. Okay, so here we go. We want to answer that question. So we're going to do that table. We're going to put the X and the Y. And then we got the relevant info. You know what I really think I should do? I should do one that does a relationship between two variables. So how about after we finish this one and we go all the way through, I'll set up another one that talks about a relationship between variables, and we'll see if that, so you can kind of see how that gets set up a little different. Okay, so here we're going to do a constraint. If it applies, right? All right, so now we go through and we read it. So we're going to have type A, that's going to be associated with X, and type takes 2 minutes. So maybe I can get a different color going. So that takes 2 minutes on machine 1. So, okay, we're going to be talking about machine 1. So I'm going to go machine 1. And that's 2 minutes on machine 1. And 1 minute on machine 2. So we got 1 minute on machine 2. So we got machine 2. And we're going to put a 1 there. And I actually meant to ask you, do you want to have me move out of the way? You can take a screenshot of that real quick so you have the problem set up. So I won't go anymore. Let me move out of the way. You can take a screenshot now. All right. Take a screenshot. Okay. All right. I'm back in it now. All right. Let's keep going. So we're going to make type B. It takes 1 minute of machine 1. So we got 1 for the Y, and 3 minutes on machine 2. We got 3 minutes there. Then we keep reading. There are 3 hours. Oops, let me switch. 3 hours available on machine 1. So that's all we can do on machine 1. So that means the constraint is less than or equal to 3 hours. This is really important that we realize this here. This is 3 hours, and these were minutes. So these are minutes. So we're going to do a little bit of conversion on that. So this 3 hours can also be written as what? How many minutes are 3 hours? So that's 3 times 60, right? Because there's 60 minutes in 1 hour. And if you wanted to kind of go through the whole units conversion thing, you have hours here times 60. I'm just multiplying by 1. The 60 minutes is 1 hour, and the hours cancel, and we're left with 180 minutes. Okay. All right, so that was that one. And now then we get to the next one. We have 5 hours available on machine 2. That's less than or equal to 5 hours, which is equal to 5 times 60, which is 300. Oh, I skipped the whole profit part at the beginning. Well, that's fine. I'm gonna come back here and do this profit part, profit. So it's $1 for each type A souvenir and $1.20 for each type B souvenir. All right, so now I've kind of dissected this problem as far as I think I can take it into this table. So that the reason I wanted you to do a screenshot is I got to erase it all. Okay, so now I got to erase all this. And we'll stop when we get right to the LP part of it. So, well, we got the table of information, the unknown. So now we're going to write the LP. So the first thing is what we need, that objective function. And it's got to have a verb. Remember, I said it's got to have a verb. It's either maximize or minimize. So it's going to be, I'm going to try to write small so I don't have to keep erasing. Maximize, I'm just going to say max profit. And so I'm going to come down here, right? And I'm going to say that the 1 is the coefficient on the X because it's in the column for X. So it's 1 times X, and I could drop that 1. And then 120, it's in the column of Y for profit, plus 120 Y. Okay, you guys see where I got that? Those are the coefficients, right? So now this is subject to Now I'm just going to take each of my coefficients on the variables and then apply the constraint. So the first one is 2x plus 3 plus 1y. I'm just say 2x plus y is less than or equal to 180. And 1x plus 3y, so it's just x plus 3y, is less than or equal to 300.
When we're doing this and it's in it's like written as time, do we have to change the constraints into minutes?
So if, thank you. These constraints, these coefficients here were given in minutes and the constraint was in hours. I could have converted these, they have to match. The answer is they have to match. So I don't care what you do it in. If you wanted to switch these to hours, you got to do fractions. So you got to say 2 minutes is 2/60 of an hour. And 1 minute is 1/60. And I just think that that's the harder way to do it. So I thought it made more sense to go hours converted to minutes.
Okay.
But does that make sense?
Yeah.
They just have to match. Yeah. Okay. All right. So then we also have non-negative constraints because obviously we can't make negative amounts of these souvenirs. And we also aren't going to make fractional. So also it's non-fractional. All right. So now let's go ahead and begin to work on this problem. So the first thing I'm going to do is the first one, call that number 1 and call this one number 2. So number 1, we have 2x plus y less than or equal to 180.
I have a quick
And so I'm going to,
question.
oh, sure, go ahead.
For profit, could you just read the values under X and Y? I just can't really see them on my screen that well.
Down here in the green.
Mm-hmm.
Yeah, that's a 1
Okay.
and a 120.
All right.
Which is what I wrote here. I wrote the 1 and the 120 on the coefficients up here on my objective function.
All right. Thank you.
You're welcome. Okay, so now I'm going to pull this 2x. I'm going to pull it to, I want to pull it over to this side so I can get this to look more like a line, equation of a line. So it's y is less than or equal to negative 2x plus 180. And that automatically is going to give me that 0, 180 y-intercept. And read it right off the equation of the line. But I still need the x-intercept. So for the x-intercept, I'm just going to go back in here. And I'm going to say, what is the x that corresponds to y equals 0? So y equals 0. And then that means that's 2x plus 0 is less than or equal to 180. At this point, I want to just set it up with an equality. And then I divide both sides by 2. And I get that x equals 90. So my answer is 90, 0. Okay. All right. The second line is going to be this x plus 3y. Is this too small? Can you guys read this? Is this okay? I'm just trying to squeeze it in.
I can't really like see it.
You can't
Like,
see it?
I can see it, but like it's kind of hard to see.
Are you looking at this on a phone
My laptop.
and your laptop? And is my window as big as your monitor screen? Pretty big? I mean, is it
Yeah.
close to it? It is?
Yeah.
Let me see if I can play around with the video settings. Give me a second. Maybe there's a way to sharpen it up. Well, this is high definition. Let me see if that helped. Did that help?
Definitely.
Yeah, a lot better.
That helped a lot better? Okay,
Yeah.
cool. All right. All right. So x plus 3y is less than or equal to 300. So again, we want to get this X term on the right side. So I'm going to subtract it over. So I'm going to end up with 3y is less than or equal to negative X plus 300. Now this next step, I'm doing this sort of in my head, but if you tend to mess it up, don't do it in your head. So I'm going to divide both sides by 3. Right? So I get y is less than or equal to, and now I'm going to distribute this as a 1/3 throughout here, right? So this is the same as 1/3 times negative x plus 300. So I'm going to distribute that 1/3 through, and I get negative 1/3 x plus 100. So from that, I get that I have 0, 100 as my y-intercept. And now I'm going to come back here and I'm going to set y equals to 0 to get the x that corresponds to it, which is the x-intercept. So I get, remember we were talking about this when we were talking about quadratics yesterday. We were talking about, well, the x-intercept is always where the height is 0, and the height is 0 when y is 0. So when y is 0 is how we get our x-intercept. So we're going to get x equals 300. It's like pretty easy. We read that one right off. So 300, 0. Okay. All right. So check in to make sure there's no mistakes. Hold on. Oh, okay. All right. So we're good there. So I think we're ready to graph. So I'm going to try to graph it right here. And I look and I say, okay, this is just like tips for graphing. Tips for graphing is, okay, my y-axis, I have a 180 there, and I have a 100 here. So I'm kind of going to go up to 200 on my y-axis and say that 100 and 100 is here. So 0, 100 is right here. And 180 is up here. But maybe we should just do one line at a time. So this is this point, right? So I just did this point right here. Now I'm going to put in the 90, 0 that corresponds with it. And I see that the other X point is going to be 300. So let's say I go out, I'm counting by hundreds. That's 1, 2, 3. So that's 300. So 90 is going to be like right here. And I'm going to connect the 180 to the 90. And I look up here and I see, oh, I'm going to be shading below that, right? Everybody see that? I'm shading below that, but I'm not going to shade it yet. You can if you'd like to, but I'm going to wait and do it when I have the overlap. So I look at the overlap, 1 point, so I can put that point in. This, we already did this point, 0, 100. Now we're going to put 300, 0. We're going to connect those two. All right, and we're also going below on that one. So if I go below on both of them, I'm going to get this area in here. And this area in here has these corners. Right? Let's call that one A, that one B, that one C, and that one D. All right. So let me just stop right there. The corners and the x-intercepts are not these numbers 180 and 300. Like, people don't get confused. You actually have to go through and do the math to figure out where your x and y intercepts are. You can't just read them off as the right-hand side of these inequalities. I saw some people doing that. So you don't want to do that. You need to do these steps. You need to understand how to graph the lines. That's why we went through the whole graphing lines part before we got into linear programming. That was the prep. We're not forgetting about it. We're not like, oh, that has nothing to do with this. Okay, so how about if you guys tell me what the corners are. So I labeled them A, B, C, and D. So we need an X and a Y for each one of those. Okay, so what's A? I'll give you a
0,
hint.
0.
Okay, thank you. 0, 0. And what's B?
Ninety, 0.
37. Okay, right. 90, 0. C, we don't know, right? It's this point of intersection. So let's come back to that one in a minute. But D, what's D?
0, 100.
0, 100. Right. Is everybody clear on that? Because this is your exam review. So ask the questions if you need to ask them. Okay. Now, how do we get this point of intersection?
I have a
What do we-
question.
Okay.
I'm just a little confused as to number 2. You only got 2 points, right? Where you did the second equation.
Yes.
Okay.
So the first one I read off of the 0, 100, I read it off of when I put this into the y equals mx plus b form on the line. This is the slope, which I don't really care about for the linear programming problems, but I grabbed the y-intercept. And that's how I quickly got this point. Okay.
Okay.
And then I went and I did the math for figuring out the x-intercept. Now I could have done the y-intercept up here too by setting x equal to 0, and I would have gotten the same number.
Mhm.
But the only part is that's more the method 1 way where you have to have a test point. I like doing method 2 because then I immediately know I'm going to shade below. Okay, so now, any more questions? Let's look at doing the point of intersection. How do we set that up? So this is where you could like kind of get stuck in the water if you don't know how to do it. Like you may go, oh, I need to get that point of intersection, but I totally forget how. So like, don't get lost in the forest here. What's the path? What's going on here? Remember what we graphed here, these lines, they came from these inequalities. So don't forget where these lines came from. So that's going to be your guide, kind of like you can follow the yarn backwards through the forest, right? Like, okay, this is how we got there. So I'm trying to find where those 2 points intersect. So it's got to be these lines, where those lines intersect. So what are those lines? Well, they came from up here, right? So how do we set up what do we do to set up to find the point of intersection? Can someone tell me?
Set them equal to each other.
Okay, what would you like to set equal to each other? This part right here?
Yeah.
So you want to say minus 2x plus 180 is equal to minus 1/3 x plus 100. That's the way you like to do it? Okay, that's totally fine. That's totally fine. So if we did it that way, I'd say we multiply fraction. So we multiply everything through by 3 on both sides. So 3 on that side and 3 on this side. And we're going to end up with minus 6x plus, oh, I forgot to grab my calculator. Hold on. So 3 times 180 is 540. And that's going to equal 3 times negative 1/3 is negative x, or negative 1 plus 300. All right, so let's add 6x to both sides and subtract 300. So if we do that, we're going to have 240 is equal to 5x. And then we can divide both sides by 5. And we get that x is equal to 240 divided by 5, which is 48. And then we just kind of want to do a sanity check. Does it make sense at that point? Is at 48 on the x-axis? Yeah, that looks. Are we done with finding the point of intersection? We're missing the y. We need that y right there. How do we get that?
Just plug it back into the equation.
Which one?
Any of them, right?
Any of them. Because these are any of these. We want the point that's going to be the height where these two intersect. So any of them will work. So you can go back up and use that one, or you can use this one. This one doesn't have any fractions, so maybe we want to use that one. That says y equals minus 2x plus 180. So we're going to say that means when x equals 48, we're going to get y 80. So what's that? So 2. I get 84. So again, let's do a little sanity check. Yep, 84 over here makes sense. I don't think I made any math mistakes. So 48 and 84 seem good. Okay, so now what do we do? What's the next step? Now we found out all our coordinates for the corners. I think that I lost track. I think that's step 3. I think that's step 3 in the method of corners. So we have all those. So now what we're going to do here is what? So let me tell you this. When you go to learn how to do linear programs, you need to know, you have to have the steps memorized. So you have to know what the next steps are. And then you have to have practice completing each of the steps. So if all you focus on is practice completing all the steps, but you don't memorize like what's the order of steps and what's the next step, then you can get stuck. So I don't want you to get stuck. I want you to know, right? So after you get the corners and after you get all the coordinates of the corners, then the very next thing is to go ahead and do what? And this is where you have to think about that theorem that tells us where the optimal solution to the objective function is.
You have to point out the maximum, right? And the minimum.
From what? How do we do that? You're on the right track.
Wouldn't you do the constraints?
Nope, we don't have to do the constraints. So the theorem that we didn't prove, that the thing that's the huge scientific discovery of the 20th century, one of the top 10, is that we can get the optimal solution, the max or min, so we can get the max of this on one of the corners of this feasible region. So we don't have to test anything else except the corners, and we figured out where those corners are. So now we got to put this in here to find that optimal solution. So that's x plus 120y.
I have a quick question.
Sure.
When you solve the point of intersection at the top, where did you get like the 3 from? I don't really get that.
Okay. So this was one way of solving that point of intersection. I'll erase it and show you another way in a second, actually. I just said, well, I don't like to deal with fractions. So I had to solve this for X. So the first thing I did was get rid of the
Oh, I
fraction by
see.
multiplying
Multiplied
both
it.
sides.
Okay.
Does that make sense?
Yeah.
Okay. So the other way you could have found intersection was to say, we're going to just solve 2x plus y equals 180. So I'm just going to take these two inequalities up here, the two constraints, and solve them simultaneously. And then x plus 3y equals 300. So I could have done it that way instead of setting them equal to each other. Either way will work. If we did elimination here, maybe I could do -2 here, and then I could get minus 2x plus, sorry, minus 6y equals minus 600, and then add this equation to it. So we had 2x plus y equals 180, and we add these together, and we would have got negative 5y equals negative 600 plus 180, which would it be what? Negative 420, I think. Yeah. And then if we divide both sides by -5, we got 420 divided by 5, and that's 84 because the negatives cancel. And so we got that same 84, and then we would just plug this with substitution. This is the elimination method. You would plug that into one of these. Let's say I plugged it into the top one. I'd say 2x plus 84 equals 180. And I've subtract 180. I subtract 84 from both sides. And I would get 2x is equal to 96, or x is equal to 96 divided by 2, right? And I would have got x is equal to 48. So that's the other way to get that same point of intersection. So you can either set the lines equal to each other and solve for x and then get the y, or you can use elimination, or if you like substitution more formally, the way you learned it when you learned solving systems of equations. Does that help with that question? Okay, so back to where we were going with all this. So we were going to all this was the entire reason we did this was because we know that, well, we trust that that theorem is true. So we knew we had to find those corners because we knew that our whole goal is to get the maximum profit. And we know from the theorem that the maximum profit is going to happen on a corner. So we had to get the corners. So we got the corners now. So now we got to actually figure out which of those corners is going to give us the maximum. So we're going to plug in the x and y into our profit function. So this is just 0 plus 0, that's 0. This one is 90 because x is just 90 times, I mean, x is 90 and plus 0. 120 times 0, and that's just 90. And then this one is 48 plus 1.2 times 84. And that's going to give me 1.2 times 84 plus 48. And I'm going to, is it okay if I erase this part over here? Is anyone still writing that? Or, okay, I guess it's okay. So I get 148.8. And then the last one is 1.2 times 100. Right, so I put that in where that y is, and I get 120. So if you look at these numbers, you're like, okay, well, the maximum turns out to be here once again on that point of intersection, just a coincidence. So annoying, but okay, that's where it is. Okay, so we would say ACE, what was the, sorry, I forget the beginning of this, the ACE something company. ACE can obtain a maximum profit a max profit of $148.80, right? So we want to convert this to money by making 48 type A souvenirs and 84 type B souvenirs. So there you go. That's the answer. So my sister, she got a degree in the College of Business, and at some point later in life went back and decided to become an echo tech. So she hasn't really been working with her business degree. She became does heart echoes. And I asked her a couple days ago, I said, do you remember linear programming by any chance? She's like, oh yeah, I totally remember it. So this might be something that sticks with you, even if you never do business in the future. So anyway, okay. Then I told you guys that I wanted to try to set up a problem that actually doesn't all fit into the table of information. And I'm not going to go through doing all the entire linear program soup to nuts, but let's go through and try setting it up. I know that there's the one available on the homework, but I figure I already did the homework solutions for that. So why would you want to see that when you have the solutions, right? You guys want to see a fresh one, or do you want me to go over the one that was in the homework on the road bikes and mountain bikes? Or does anyone know of another one that they got stumped on? Oh, all right. Let me see if I can find one. If anyone knows of one real quick that they can think of, let me know. The most common thing. Oh, here's one. Okay. Allocation of funds. Okay, this is Madison Finance. So Madison Finance. This is not unlike the quiz, actually one. Has a total of $20 million earmarked for homeowner loans and auto loans. $20 million. Earmarked for home I'm just going to say home loans and car loans. Period. Okay. On the average, homeowner loans have a 10% annual rate of return. So on average, home loans have a 10% rate of return. So I'm just going to say R little o r. Whereas car loans yield a 12% annual rate of return. management has also stipulated that the total amount of homeowner loans, so I'm just going to skip the part about management also stipulated. I'm just going to say what they stipulated. So also, the total amount of homeowner loans, home loans, should be greater than or equal to 4 times the total amount of car loans. So maybe this problem could have been a little trickier if they had said the total home loans should be at least 4 times the total number of car loans. So another way that this could have been worded, just so you get comfortable with this kind of wording, is this should be greater than or equal to, could have said should be at least, is another way that this part could have been in there. Right, so that doesn't say cat, that's parentheses, and that says at least. That's an alternative wording for that. All right, so finally what we're asked to do is determine the total amount of each type so that they could maximize its returns. So how many of each loan should Madison Finance what's the word they use? Extend to maximize their returns, its returns. All right, so this is a good problem in as far as trying to convert it into a linear program, because it has that element that we haven't seen that many examples of, which is where we have a relationship between the variables. So let's go ahead and get to the question and figure out what the variables should be. So I would like you guys to try to do more of this than me. All right, so that way you kind of start hopefully feeling confident. So let's go right to the question, and I'm just going to underline it. It says, how many of each loan should Madison Finance extend? Okay, so can someone tell me what X and Y should be?
The car loans, and then the other one should be like the house loans.
You fell into the trap of not giving me a number, but you're on the right track. So rephrase it.
Would it be the interest rate?
Nope. Let's read that question again. And it actually tells you right here. How many of each? So it's the number. This is how many. So it's the number of home loans. And it's the number of car loans. Can you see how I did that? You want to take that question mark and then you want to read it. And if you have to read it 3-4 times, whatever it takes, but it's going to tell you what the variables are. So it says how many of each loan. So I know I have to, I go back and I'm like, okay, how many loans did I have? Okay, And they could have talked about 5, that's more advanced, but this one's talking about 2 kinds of loans, home loans and car loans. So it's how many of each. So I have to use this word number or amount or quantity, something that I'm going to answer with a number. And so number of home loans, number of car loans. Does that help?
Yeah.
You see that? You see that first step, okay? Because remember I said that first step is key. You want to know how to set it up. All right, so now let's do our table of information. We're going to take the X and Y and they're going to be our columns. And we're going to add columns on either side. So over here, we'll have irrelevant info. And over here, we're going to have maybe a constraint if we can find it. All right, so now let's go back and reread the problem and start filling in the table. Now that we know we have X's info, everything below X is going to be stuff about home loans and everything about in column Y is going to be car loans. All right, so we go through and we have Madison Finance has a total of 20 million earmarked for home loans and car loans. All right, so right away we know we got, it's just like the quiz problem. You have a total amount that you have that you're going to deal with. All right, so we have total amount. I don't know if we need that information. Because this is the number of each. And this is referring to the amount of money. I'm not sure we need this 20 million because it doesn't, there's no information about how the quantity, the size of the loan. So let's just put it in here, but I'm going to put a question mark by it. Okay, so this also is a good problem. I haven't given you guys any like this, where you have extra information that you don't need. So this might be a good example of having, you know why I say it's good? It's not because it's tricky. It's more like the real world. You have to pull out what is the information that you need for the problem and what is the information you don't need. Okay, I already wrote the exam, so you're lucky. Okay, but okay, Madison Finance has a total of 20 million earmarked for home loans and car loans. Okay, now let's keep reading because we just know the total amount is 20 million. Okay, on average, home loans have a 10% rate of return. So rate of return for the home loans is going to be 10%. So we're going to have a 0.10. Where was that? So we're talking rate of return. So we have home loans have a rate of return 10%. And we're going to remember, we're going to convert percentages by moving the decimal 2 to the left. So that's a 0.10. Car loans yield a rate of return of 12%. So that's 0.12. That's just rate of return. Sorry, I should know at home. Okay. You guys see that? Any questions on that? So the total home loans, so we keep reading now, total home loans should be greater than or equal to 4 times the total number of car loans. So if this problem had been worded a little trickier, it could have said total home loans should be at least 4 times the total number of car loans. So when you get into something like this, it doesn't really fit in our table. And our table is really meant to be a tool. You don't have to fill it out. It's a tool that is that bridge, like I told you, to build your linear program. So in this case, when you have a relationship between the 2 variables, the 2 unknowns, you're just going to need to just write your constraint out on the side. It's not going to really fit in the table. So in this case, we say the first thing to identify is you're going to have an inequality and you want to know which way to put it. So figure out which one has to be the bigger one. So when I read this and I say the total home loan should be at least 4 times the total number of car loans, which is there more of, home loans or car loans?
Home loans.
Right. Oops. So there's more home loans than car loans. So it's going to be greater than or equal to. So this problem was nice in that it converted it to sort of a little closer to math, right? It's greater than or equal to, so we know that. So the number of home loans should be greater than or equal to 4 times the number of car loans. So X has to be greater than or equal to 4Y. Okay. Now we keep reading. We're not thrown by the fact that this doesn't fit what we've seen before. We keep plugging away at it. So total home loans should be greater than or equal to 4 times total. Okay, we got that part. So how many of each should Madison extend to maximize its returns? Oh, okay, we want to maximize this. So I'm going to come back here and write max on that line. All right, so now we're going to write our linear program. Oh, actually, I'm going to take this X greater than or equal to 4Y, and I could leave it like that. That's technically not wrong, but I know for a lot of you, you're like, that looks so weird. I don't know how to deal with it. If we subtract 4Y from both sides, we could get X minus 4Y is greater than or equal to 0. And that looks a little bit more like we're used to. All right. So now let's write our linear program. The linear program consists of an objective function.
Is there going to be a question like this on the exam? Because this one's a little different than the ones that we've been doing.
What I will promise you is that I did not have problems that had extra information that you had to ignore. Because in this one, we're ignoring the fact that it was a total of 20 million.
Okay.
So that's other than that, it's, if you ignore the fact that it had this extra information that we had to realize we don't need, that's the part of this problem that I will be forthcoming and say, I'm not expecting you to throw out information yet. You're still too new at doing these. But anyway, so let's go back to the objective function, because otherwise this problem is very similar to ones you've done in the homework. And I think in at least 2 or 3 homework problems. Okay, so the objective function is, let's find it. It's this rate of return. So let's just call it R. And that's because, we want to maximize. Remember, we need a verb. We want to maximize. R equals 0.10x plus 0.12y. All right, so the next thing we're going to say is subject to, because we have to put our constraints in here. Oh, this was not superfluous. So why did I realize that? Because I said, oh, wait, we need 2 constraints, because remember, you need at least 1 constraint for every variable. So we have the first constraint, which is X minus 4Y is greater than or equal to 0. I still don't like this problem. Maybe I left something off. I think that, well, we know we have that constraint. We know we have that. See, I think what they meant to say or do was have us say X plus Y equals 20 million, as if so I think they messed up when they wrote this problem. Because this is referring to $20 million, and this, and X and Y is the number of loans, not a quantity of loan amount. So they messed up when they wrote this problem. They needed to have, they needed to say something like has a total of, if we erase this problem and erase this information and say that has a total of, I don't know, 50 loans earmarked. So just a quantity. So that's not referring now to a money, because these X and Y's can never address that. So then we could have said X plus Y is less than or equal to 50. So their max number of loans they could give would be 50. All right, so that would be a situation where we'd say the total loans. And we could say 1, 1. And then here we would say a total of 50. And you could either say equals 50 or is less than or equal to 50. Okay, so I thought it was a good problem. It turned out to be a really bad problem because they worded it badly. So that's the way if that problem originally, like I said, had said a total of 50 loans, so it was referring to something with quantity, we could have then created a constraint around it, that X plus Y would be less than or equal to 50. Okay, so hopefully that didn't distract you too much from the main reason I wanted to do this problem is that it had a constraint that did not fit in the table. That was a relationship between the two variables. Okay, so that's those are the two flavors of linear programs we've covered. Okay. Any other questions? Or questions about this or anything else? We have about 3 minutes left. Okay, sounds like people are dropping off. Okay, well, I hope you sleep well and don't get stressed out. Just learn all, know all this stuff and review all the solutions to the homeworks and the quizzes. So you're sure that what you're doing is right. I would make sure that's definitely something you want to be sure of.
Thank
Otherwise,
you.
Thank you. Have a
Oh,
good one.
Thank
You're
you.
welcome.
Thank you.
Bye.